Alright guys, today we are going to talk about solving two-step equations. So kind of just adding on a little bit of what we did just the other day, which were one-step equations with the rational coefficients. So here we go, solving two-step equations. Go ahead and grab your notebook if you don't already have it out. Green on the left, notes on the right. We only have one phrase. So go ahead and grab it and be ready to go. Okay, green on the left, notes on the right. Here we go. Solving two-step equations. So the only phrase we've got is two-step equation, everyone. All right, so here we go. The book says it is an equation that contains two operations. An equation that contains two operations. So here's a real basic one, but 15 equals 3x plus 6. So write that in your example box. Two operations, the addition and of course the multiplication between the 3 and the x. Okay, so that is it. So go ahead and take your notebook. You can put it right back away. Grab a piece of paper and your book and go ahead and turn to page 336. Okay, on your page there, on your paper, of course, write down your assignment. All right, assignment number 15, book page 336. Okay, here we go. The very first one, just go ahead and put your pencils down. Let me just go through this really quickly. Just going to do a quick review on something that you guys did in elementary school. Starts off very basic. So here we go. Number 28 in your book. And again, pencils down, guys. I'll let you write I know this is part of your homework. I'll let you write it down as soon as we're done. So it's 3b plus 15 equals 27. All right, so here we go. The very first thing is I'm going to go ahead and I'm going to find my variable term, meaning the term with the variable in it, right there, 3b. Okay, now what I'm going to do is I'm going to go to that exact same side of the equal sign. All right, and what I'm doing is I'm going to look at the other term on that side of the equal sign. In this case, it's the positive 15. That's what I want to get rid of first. So on most of these, not all of them, but on a lot of them, I'm going to do the additive inverse first. Okay, the addition subtraction. So here we go. I'm going to go ahead and, since it's positive 15, I'm going to do subtraction of 15. Remember, I'm going to do it to both sides of the equal sign. That's gone. Remember, inverse cancels out. So I bring my 3b down. I bring my equal sign down. And then, of course, 27 minus 15 is 12. Now it's just a one-step equation. So I, of course, find my variable, which is the b. Of course, stick to that side. It's just the left side there. It's being multiplied with 3. So we talked about this the other day, right? We do the opposite, which is divide by 3. Write it in fraction form, our division. We work downwards. And then the inverse cancels out. So we have isolated the variable. B is equal to 4. Alright, so just a basic two-step equation from elementary school. Alright, so go ahead really quickly, write that down. Grab your pencil, write that down. Give you guys, I don't know, 20, 30 seconds to write it down. Okay, so let's go ahead and let's do number 32. All right, a little more of a advanced Math 7. Oops, it's 1/9. Advanced Math 7 problem. So we have 1/9 h minus 3 equals 2. Okay, so here we go. Same idea. I'm going to go ahead, find my variable term. I know that the coefficient's a 1/9, right, a fraction. So, but what I'm concerned about first is my additive inverse, my subtraction of 3 with the h. I'm going to go ahead and do the additive inverse. I'm going to do the opposite. I'm going to add 3. Again, that is step 1. All right. You can put a little addition, subtraction sign there to tell you that for the most part, that's what you do. All right, so additive inverse, subtract 3, add 3. I'm going to go ahead and add 3 to the other side. That cancels. I end up with 1/9 h equals, okay, 5. And of course, I'm getting a little behind on steps, right? We did additive inverse here. Step 2 is do the same thing to the other side. Step 3 is solve, okay? Or I should say solve at least that part. So here we go. Step 4, and here's all I'm going to put. You're going to repeat the same steps. This time, though, of course, with multiplication and division, okay? Your multiplicative inverse. So here we go. I'm going to go ahead. This is just last Friday's homework. Okay, so remember it's h is being multiplied by 1/9. We can divide by 1/9. But remember how we cut out the middleman, right? So instead of dividing each side by 1/9, we go ahead and we multiply by its reciprocal. Instead of 1/9, we multiply by 9/1. And so if we do that to the other side, I'm going to have to squeeze it in here because my notes. So remember, those cancel out. We have h left over equals, and then 5 times 9/1, or 5/1 times 9/1 is 45/1, or just 45. Okay? So it's just like Friday's homework, just the one additive inverse step right before we solve the rest of the problem. Okay, here we go. I'm going to have you guys try one. So go ahead and try out problem, just 2 problems later, problem 34. Try out problem 34. Okay, go. All right, 30 seconds. Go ahead and turn to your neighbor. Share your, make sure that you guys share not only your answer, your whole answer, but of course, take a look at the equation if you guys don't agree. All right, so 30 seconds. Go ahead and share. Go. Okay, so number 34, just check your work here. All right, number 34 was 20 equals 1/5 m plus 12. All right, so your finder variable happens to be on the right side of the equal sign this time. I have my variable term, my 1/5 m. I look at my other term, which is just my plus 12. So I start there. I do my additive inverse, just step 1. I subtract 12 here. Step 2, of course, is balance out the equation. Do the same thing to the other side of the equal sign. So that's gone where we did the inverse. 20 minus 12 gives us 8. So, of course, we're solving with step 3. So it's 8 equals 1/5 m. And then remember, now we need to get the variable isolated. So again, it's being multiplied by 1/5. We can divide by 1/5 on each side if we'd like, but instead, I'm going to go ahead and do, I'm going to multiply by the reciprocal. So I'm going to multiply by 5 over 1 here, 5 over 1 here. So these cancel out, of course, and we go ahead and go with m equals, and then, of course, 5 over 1 times 8 over 1 is 40 over 1, or just 40. Okay. Let's try one more together. All right, so let's go ahead and go to problem 66. Problem 66. It's on. It actually goes over to the other page on page 337. All right. Okay, these are some challenge problems. So we're going to go ahead and take a look. And on 66, right, we have x over 2 plus 5x over 6 plus x over 4 equals 380. So guys, this is a lot like our problems the other day. How we ended the lesson the other day is, and that is, remember, there's a little bonus step at the very beginning, and that is simplify. That's our bonus step. Simplify the one side if you can. Well, this looks kind of weird, but ultimately they're all fractions that do not have common denominators, and if we're going to add them, we need to have common denominators. So if I take a look here, finding a common denominator is finding the least common multiple. So what I'd like to do is take the bigger number. 2 can go into 6, but 4 can't. If I take the big number and I double it, that's 12. You know what? 6 goes into 12, 2 goes into 12, so does 4. All right, so here's what I'm going to do is I'm going to, this is all under step 1, I'm going to simplify. I'm going to find common denominators, I should say, of each one of these. So denominator of 12, 12, 12. Okay. So if I have this, okay, since there's 3 of them, I could stack them to find a common denominator. But what I'm going to do, of course, is just know, right? 2 times 6 is 12, so x times 6 is 6x. If you don't know what I'm doing, 2 times 6 is 12, x times 6 is 6x. 6 times 2 is 12. 5x times 2, well, 2 times 5 is 10, so it's 10x. And then 4 times 3 is 12, so x times 3 is 3x. We have common denominators. I'm now going to go ahead, I'm going to simplify that. This is kind of nice because look, denominator, when they're all the common denominator, it stays as a 12. My numerators are all like terms. 6 plus 10 is 16, plus 3 is 19. So we have 19x equals 380. Okay, so looks a little weird, right? So here's what we can do. I can't remember if I talked about this with you guys or if it was just my Math 7 class, but if you have an x in the numerator spot, you can actually have an equivalent fraction as making your 19/12 your coefficient and bring your x over to the side. It's actually the same thing. If you don't believe me, think about it this way. If we had 19/12 times x, if I was actually to do that, when I just put x over 1, which would give me 19x over 12. So that's how that and that are equal to each other. Just a little side note there. So if I have x in my numerator spot, I could bring it out and use 19/12 as my coefficient. So at this point, now it's just a one-step equation, all right, with a rational coefficient. So I'm going to go ahead, or a fraction coefficient. I'm going to go ahead and do what we've been doing. I'm going to go ahead and multiply by the reciprocal here, multiply by the reciprocal here, 12/19. Okay, so these cancel out. We end up with x equals, now here's the nice part, is I know that 19 and 38, right? 2 19s equal 38. So I know that I can cross reduce this by 19. And that up here, of course, gives me 20. And if I multiply straight across, 1 times 1 is 1. 20 times 12 is 240. So x is 240. Oops. Okay, guys. Go ahead and try 64. Good luck.